Actually, it's probably worth saying that in the cloud, certainly, we find that I/O is one of the biggest bottlenecks, right? I mean, people want to be network bottlenecked, and you know, just from capacity or just from performance-wise, they can be in our systems, for example. But if you try to write more to a node than you can write to disk, eventually memory will blow up, of course. And so we actually find techniques for like I/O deduplication and so on are very important. That you just try and write less to disk than you receive in as writes, which you can often, because often the nature of the data in use cases where NoSQL fits very well is so that the same key or the same document gets updated very, very quickly in succession. And so actually artificially and asynchronously delaying the writes to disk is for many users something that they want, so that instead of writing the 10 updates, you just write the final state of the data after the 10th update. And if you can do that across your data, you've just cut your I/O bandwidth needed into 1/10, for example. Clearly doesn't fit for all data, but for there's a lot of data out there where that fits, and then you can get around having to go to really expensive I/O or lots and lots of nodes and still get persistence to disk.
Yeah, we're on EC2, and we use elastic block storage, and we RAID on top of that, which is a little bit strange, but EBS is kind of a weird beast.
Especially when it goes down.
It's not as reliable as one would like.
I was just going to make the observation that the big thing about SAN versus direct attached storage is the ability to migrate hosts and reconfigure hardware. If you are on a SAN and somebody throws a brick through a server, you can reconstitute the server. If it's directly attached, the brick just went through the drive.
Yeah, but what if someone throws a brick through the SAN?
That's why you have multiple SANs in sync, but yeah, you have to be careful how you build it. For high availability, the problem is that every time you add nines, you have to be that much more careful.
So this is I think
Yes.
this is a great slide, which is kind of this visual guide to NoSQL systems. Yeah, exactly. You pick two, and this is kind of putting the different systems into their different categories. And first, I kind of want to ask, especially the shops guys, what do you think of this, and do you think this accurately portrays where your product aligns in the guide?
So Cassandra could actually be AP or CP based on the consistency model. So we're actually flexible there.
But you can only do one or the other?
Well, it depends per query for us.
Okay, so
it's tunable.
This is this diagram. I mean, it's a famous but very poorly understood by most people diagram. So it's easy to throw this up on a screen. It's a lot more difficult to really understand what it means a lot of the time. What most people think consistency and availability mean is not really what this diagram is actually saying.
So inform us.
That's a
yeah. I'm not
Long
going to do that in
okay.
2 minutes.
there is some info on the MongoDB blog about this, but it's a 6-part article. So if that tells you anything, so go check that out.
Would I be out of line by arguing that any of the 3 databases here, at least as described, can be configured to be any 2 of the 3? You just can't get all 3 for any given data items a killer?
You can't really do CA except on a single machine, because if you don't have partition tolerance, that basically means you're going to get incorrect operation. Because if you think about a single machine,
Right,
if you imagine it partitioning.
But if you can't do CA and be cheap.
You can't do CA at all. The only way you can do it is with one server, basically, or 2 servers.
Well, 1 server per some unique way of sharding.
A network has to cease to exist for that to work, or at all. So yeah, you can do it on 1 server.
Yeah, and I think what's happening there is that 1 server isn't tolerant to partitions. It's very rare to have a partition on 1 server, right? Imagine the memory bus stops working, right? That's a partition. But it doesn't happen very often.
I had something to add to this a little bit. So we talked a little bit about developer productivity, and somebody brought up use cases in one of the discussions, and this is absolutely spot on. Classically, the developers at our company would design applications, work with DBAs and schema changes, et cetera. Now it starts at product management. They define the use cases, and the developer takes the use cases and develops their app. The same use cases define the data. And we kind of move between CP and AP depending on those data attributes in the use cases. It's a game changer for us.
That's very cool. Yes.
I have a question concerning the model that was shown before concerning Cassandra. Picture had 4 nodes right here. Question, just a general question, not just on Cassandra, but I guess all the NoSQL products. What would be the metrics for consistency? 2 nodes, 3 nodes? Is there a specific algorithm that determines when you have enough consistency to stop worrying about a write that went through?
I think that depends on your use case, because in some scenarios, like you're a great example actually. A lot of companies choose to have 3 copies in a single data center because that means a machine fails and you still have high availability. In his scenario, he went to 2 data centers and they maintain 3 copies at each. If you take that a 2 data center scenario, they did that because if they lose a data center, it's okay. If you go down to Wall Street, you can't lose a data center necessarily. So you might need 3 data centers. So you can lose an entire data center and still have high availability at that level when you start talking about trillions of dollars. And so I don't think there's a silver bullet for your answer, but I think it goes back to his point of it's really about the use case.
And I think we're at the point now, if anyone else has any questions for our illustrious panel here about any of the topics we've discussed. Yes.
Going back to standardization, is there any, I know we touched upon it before, but from the programmer's perspective, with like the different APIs, like the REST APIs, or like I think Mongo has a custom API or custom drivers for individual languages. Is there any effort in that direction to standardize, at least from the API perspective?
Not a lot. No. I mean, I think Dwight's correct. Like, I think that it'll become more standard over time, but it's certainly not going to happen in the super near future.
Even though maybe from my perspective, I think there's also a difference between querying and the data operations, right? Because these days, I mean, the data operations are typically fairly straightforward, and whatever you call that, a get operation in your API or in your SDK, it's not too confusing, I think, for programmers typically to get their heads around that. Plus, of course, often in the frameworks, you get some sort of abstraction anyway where you want differences because frameworks specifically, you want to interact with the data store differently. You don't want to go directly and say, now go and get me this document necessarily. You want to work at the object level more and use that. But I think at the querying part, that's going to be the interesting area because just like in the relational databases, I think that is where you will have more complex things to describe, and that's where standardization, I think, will be beneficial if and when it happens, and I'm sure it will happen eventually just because at one point the users will speak and say, well, we want a standard because we don't want to learn something new all the time when we change. All right. Well, thank you, everyone, for being here, sticking through all of this. I appreciate it. Thanks to our audience, panel. Thank you, guys.